Thanks, Paul, for coming to present today.
Thank you, Daryl. So good morning, everybody. If you're all ready. So my name, like Daryl says, Paul Long. Today I'm going to talk about Network Monitor 3.4. So first of all, how many have used protocol analyzers in the past? Okay. And so the rest of you know what a protocol analyzer is? How many people know how many people don't know what a protocol analyzer is? Okay. Well, there's other ones. Wireshark, you might also be familiar with. This is another one I think some of you have used before. But today we're going to talk about Microsoft Network Monitor, in particular the latest version is 3.4. So who am I? I'm the technical evangelist for the team. We have a blog that I write on TechNet that has lots of information about using the product, troubleshooting, networking in general. We also host a Connect site when we put new versions out, betas and such. And there's some other links that I have at the end that we can share with you. So previously, before coming to this team, I was in the critical problem resolution team on the networking team. So I did troubleshooting myself. We did corporate level support, and I work out of Charlotte, North Carolina. So if you ever get in touch with me, I'm on the East Coast. And then finally, a personal note, I built a recording studio out of what was my two-car garage. So I'm into music, recording, stuff like that. So here are the key takeaways. This is what, if you forget everything else, these are kind of the main points that I want to kind of drive home. So first of all, how to capture, filter, and find trace data. Just some basic things that you do with the protocol analyzer. I want you to be able to find interoperability issues without reading the protocol docs. So as I'm going to explain in a little bit, we based our parsers off the protocol documentation. So sometimes you can find issues with your implementations by simply running a trace and looking for errors and problems. And then finally, learn how to document issues and annotate captions. So this is the idea: is you have some issue and you want to present it to Microsoft or present it to a protocol document support team. And this is just some tips of how to grab information out of Network Monitor to make it easy for us to deal with that type of data. So this is just a quick background to give you some idea of where we came from. So Network Monitor started out a long time ago. Network Monitor 1.x and 2.x was in the early 90s. And then there's this period of time I call the Network Monitor Dark Ages where nothing was done. The parsers weren't updated. It just sort of sat around. It was used to take captures and look at captures, but there was no active development done on the product. And so we came along 2006, and we started up a new version, and we've since put out new revisions every 9 months to a year, more or less. And so we had a new vision, a new team, a new design, a new idea. So we wrote Network Monitor 3 from the start. There's no shared code from the past. In fact, there's sometimes people say, hey, do you have this feature anymore? Well, we rewrote everything from the start. So if it's not been added back in, then it's not there. But we have brought forth most of the ideas from the original version. And then we had some very general goals for Network Monitor. And these are kind of important. Probably the most important one was accuracy of parsers. We wanted the parsers to be accurate and to be able to decode any kind of Microsoft protocols that we had documentation for. So accuracy was key. Easy to capture and filter. We wanted to make these key scenarios really easy to do. Safer. In Wireshark, they have this idea of dissectors and DLLs and such like that. And we had the same mechanisms back with 2.x. The problem, as you all know, DLLs have potential for injections. They're just not as safe. So we wanted to make a safe model that we could build parsers and not have to worry about these issues, because often these tools are run on production servers, and so that was important to us. We wanted to boost performance, or at least think about performance and try to make things as performant as possible. And automatable. We wanted to allow you to script things. So if you needed to do things in a scriptable manner, like repeat captures, repeat filtering, that parts of it was automatable. So that was another main goal. So that was the intro. Any questions so far? No? Okay, so this is my red bus tour. I don't know if you all have been to London, but they have these buses that fly around the city, and you get on a bus, and there's this person in the front that says, hey, you've got this building over here and this building over there. And then sometimes you can get off the bus. So we'll get off the bus sometimes, and I'll show demos, and then some of it I'll just talk about. But if there's any questions, feel free to ask. I can demonstrate what we're talking about for you on the real tool. So we're going to go over these topics. You can read them, but we're going to basically going to go over it again. So here's the start page. This is what you see when you first start Network Monitor if you haven't double-clicked the capture file and bypassed it. And so this has some interesting things in it. We have the recent captures. So if you've opened the capture before, you can get to those recent captures right here by clicking on them. You can also open a new capture. Start a new capture session. We have our network interfaces over here that you can select, and these are kind of saved as default for any future sessions. You can change this later, and you can actually change these on the fly when you do a capture. So if you started a capture, you can check a box under the properties and get them to start capturing live in the middle of the capture. And then we have this news page over here, which has information, links to the blog, links to our forums. In fact, everything you probably need to know as far as where things are on the web is in this start page. Plus, we have a list of our latest features there as well. So it's a good thing to know if you need to find out information. Just start here. So let's just talk about the capture tab. Now, the capture tab and looking at a trace are very similar. The main difference is that you have, start and stop buttons to start and stop the capture, a capture configuration, just a couple of extra things. But everything, there's more things in the capture tab than there is when you're looking at a trace, so you see most of the same stuff. So at the top, you have the display filter. So this is where you would type in your filters to narrow traffic down. If you want to see TCP traffic, this is where you would type the filter, TCP, and we'll go over the filters a little bit more detail. On the right side, we have network conversations. So this is something that if you use other protocol analyzers, this is something new, this is something different. It's basically a way of collating data, taking different threads of traffic and collating it for you so that you can click on a process, click on Outlook and see just the traffic for Outlook, or click on a specific port connection and see just that traffic. And we'll talk about that in a little bit more detail as well. Frame summary. This is the list of all the frames in your trace. I don't think there's anything terribly difficult or unique about that. Frame details. This is also another typical thing. So once you select the frame in the frame details, in the frame summary, it shows you the frame details, which you can then select something in there and further map it to the hex details if you want to see more detail about what that looked like on the wire. Any other questions? Any questions? No? So capture settings. This is what I told you is that you can modify the capture settings. You can select adapters once a capture is running or before you run it once you're on the capture tab. All the interfaces show up here. You actually see, so you think that you just have interfaces for your network cards, but there's actually other things. Tunnel adapters that show up here. Endless WAN is the option here for VPN type traffic. So there's other options available to you. And then you can also optionally apply a capture filter, meaning that you'll apply the filter before we even save it to the file. So you'll never see this data again if you filter it out. There's some dangers with that we'll also talk about in a little bit. But Network Monitor is not just a GUI thing. We also have a command line tool. So there's lots of cases where a command line tool has advantages. First one is that it's scriptable. And this is the automatable part of Network Monitor, by the way. You can script the capturing, filtering with NMCap. And this is in the path automatically. So it's automatically in the path. Once you install Network Monitor, you can go to command prompt and type it, so it's kind of convenient. Has the highest performance. If you're worried about slowing down a server or causing issues on a machine, use NMCap. The UI is not meant for long-running captures or high performance. Filtering is just like the UI. There's no special filtering. And by the way, our filtering is the same across all our components. I'll explain. You can capture live or you can capture from a file. So you might have an instance where you've got this large capture and you need to break into smaller chunks, or you want to filter out certain port traffic, or you want to automate something. NMCap can take another capture as input. In fact, multiple captures as input. NMCap has special options for saving. For instance, the chain captures. It can chain captures together, but it can also capture files, capture in different methods. So it can do a circular capture, where it just overwrites itself after it reaches some maximum size, like 100 megs, and then it just starts from the top. So you can leave it running for a long time and not worrying about filling up your drive. But it can also do chain captures where you want 100 megabyte chunks of files. That's another option. But it can also chain capture files together. You can take a bunch of files that were apart and use NMCap to stitch them back together. And I actually have a blog about this. And then finally, there's rich start-stop features. So you can stop and start when you see specific traffic. For instance, if you wanted to wait for a certain event to occur, you could trigger some traffic on the wire and cause NMCap to start or stop. You can also do it by time, in 10 minutes, tomorrow at 4 o'clock, whatever. There's lots of features inside NMCap, and none of this is available in the UI. So here's a little chart I made just to kind of show you some of the differences between NMCap and the UI. Capture options, circular chains, as I mentioned, is NMCap specific, the highest performance, automatable, flexible. They both do application tracking information. So this is the idea that you can capture process info and see it in the UI so that you can click on Outlook and just see Outlook traffic. Now keep in mind, this is something our tool does. Wireshark doesn't do this, other tools. So you have to capture with our tools in order to get the application, the process tracking info in the trace. The UI has a special mode. Yes? So what we do is we capture, so the question was, what does application tracking information mean? And so what we do is while we're capturing, we query the TCP tables and associate processes with TCP traffic and save that in the capture file. So what this means is that if you do this in the UI and you start a capture and Internet Explorer sends some information out, we capture that and show you Internet Explorer in our conversation tree, and we keep that information in the file so that you always know that this traffic came from a certain process. So it's something we capture specifically. We add it into the capture file format. Any other questions? Yes? And why what? Okay, so wireless monitoring the question is what is wireless monitoring and why is it only in the UI? And so what it is the ability to capture a special management mode that's enabled by specific, in fact, a lot of different wireless adapters today, to capture the traffic, the monitoring traffic that happens, for instance, before you actually associate it to an access point. There's certain traffic that goes on. So you can sit there, for instance, you can sit there in this monitor mode and see all the broadcasts from all the wireless adapters. It's only available in the UI because there's certain, because we never enabled it in NMCap, we could have, but there's certain features like how often you want to, what Wi-Fi radio do you want to listen to and how long do you want to listen to it? And we didn't expose those types of features from NMCap. Now, that's not to mean that you couldn't, there's actually a separate tool, an executable, that what it does is it puts the wireless adapter into this special mode. So you could actually run the tool and put it in that mode and then start at NMCap and still see the traffic. It's just not built into the command line. So it's possible, it's just not part of the interface. Auto scroll, any other questions? Yes? Okay, so the question is what is the circular and chain mode for the capture options? And they're basically, when you do a capture, the circular capture is the default with NMCap. In the UI, we capture forever. We capture everything. We just keep on going until we run out of disk space. So it's not a great option for long-running captures. But in NFCap, a circular capture means that you start capturing and you give it some size, let's say 100 megs. And what happens is once we reach the limit, we don't fill up any more disk space. We just go overhead and right over the oldest frames first. So that's what we mean by circular capture. Chain capture, on the other hand, you specify a size, and each file is a certain chunk. Each file is a certain size. So you'll say 100 megs, and it'll get to 100 megs, and then it'll start a new file. And basically what it does is just number it 1, 2, 3, 4. And so some of the advantages of this is that you can access the old data while the capture is running. So once you get to 200 megs, it moves on the next file. Now you can open that file and look at it. And it also gives you smaller chunks to manage if, for instance, you know that it happened during a certain time and you know the time span of that particular file, which you can figure it out. It's not obvious, but you could say, okay, I know it happened between 10 and 11, and that's in this file here. Then you just send one file rather than a huge 2 gig tray. Makes sense? So auto scroll, obviously, is more of a UI thing anyways. Frame truncation you can do in both. Multi-home, meaning you can capture on multiple interfaces at the same time. This is something unique to our product. So if you have a machine that's a firewall, you can capture both NICs at the same time, and it'll be in the same trace. And then promiscuous mode, this is the ability to capture traffic that's not destined for your machine. And we actually have a slide specific on that because it's important. And this is why promiscuous mode is important. So here are some tips on how to do captures. Make sure you get the information you need. The first thing is, and maybe it seems obvious, but the traffic has to arrive at your capturing machine. So the reason this is important is because switches and routers are very smart these days, and they filter out traffic that isn't destined to your machine. So for instance, if you have 3 machines, and you're capturing on one, and you have 2 machines capturing A and B, talking to each other, you're not going to see that traffic unless, 1, the router forwards it to your box. So there's options sometimes on these routers to do mirroring or port spanning. You might have to enable it to see this traffic. And then the second thing is you have to put the machine into promiscuous mode. So NIC cards, the interface NICs by nature only look at traffic that's coming to your machine. They're not going to take anything else. So you can stick the card in this promiscuous mode, and that'll see all traffic. Any traffic, even if it's not destined for the machine, will be captured by that NIC. So the other important thing about capturing is avoid too much capture filtering. So the tendency might be that, okay, well, I really don't need anything but HTTP traffic, so I'm going to go ahead and capture only HTTP. Well, the problem with this is that when we capture, we don't know that fragments are necessarily going to belong. We don't do any on-the-fly reassembly. So if you filter on anything that just has an HTTP header, you're going to miss all the fragments, all the TCP fragments. So this is a bad practice. You know, if you say, I'm going to get SMB traffic, type SMB, you're going to miss what you really need to get, or potentially miss what you need. Filtering on stuff like MAC and IP addresses, TCP ports, they'll probably be safe. Probably be okay if you need to filter on that, because at that level, things are pretty, you have a good chance of getting what you want. Now, the caveat here is that, you know, if you're looking for HTTP traffic and there happens to be some DNS traffic that's happening, well, you might want to see that too. It just depends on the situation. So I actually, if you can, if there's no reason, just don't even do any capture filters. You can always filter it after the fact. Maybe the only reason you want to apply a capture filter is if you have so much data, you need to figure out how to cut down the hose pipe. But we'll talk about that in a second as well. So drop frames. So this is a reality these days with 10 gig, 1 gig networks. You can't avoid, in some cases, dropping frames. So we have indications in the UI and in NMCAP when frames are dropped. And you've got to keep track of this. So if you start a trace and you see that drop frames are happening over time, all right, I got a problem. I got to figure out what to do. I cut down my traffic, maybe use a capture filter. But you got to pay attention to this. If you don't, you might miss the data that you need. And so here are some reasons that drop frames occur. The high-speed networks, a complex capture filter can cause frames to drop. When we're doing a capture and doing the filter, we have to evaluate every frame. We have to say, all right, do the calculations. Is this the value? That takes time. And so if it takes too much time, then we might also drop frame. High CPU utilization and slow disk. So these are kind of external environmental factors that are going to affect your ability to capture a trace. If your CPU is busy doing something else, it's not going to have any time to do our filtering. So it's another consideration, and maybe a reason you want to do capturing off-box in some scenario. And then the final one is this complex parser file. So one of the issues we have with our parse engine is the more parsers that you have loaded, lots of questions. Okay? Yes? So the question is if this number is 0, is that a reliable indication that you haven't dropped packets? And the answer is yes. I mean, we get this information from the driver, from the NIC itself. This is the same number. Well, it's a combination of things. So dropped frames means either the NIC dropped it on the wire, so we get an indication directly from the NIC that it dropped a frame, so it should be accurate in that sense. And it could also mean that the NIC passed it up to us, and we dropped it. So it's kind of a combination of two things. But yes, it should be accurate, just as accurate as the system is or the NIC is. Is there another question? Okay, so the question is this going to take care of your infrastructure? So if it gets dropped on a router somewhere before it reaches the machine, we don't know that. It has to at least arrive to the box. You do get retransmits. We're going to collect those, and you can determine that inside the trace via filter. Any other questions? Okay. And so this complex parser profile I was talking about is that depending upon what set of parsers you have loaded, affects the speed at which we can filter. So in some cases, you can simplify the parser because maybe you only need TCP port. You can simplify the parser profile and get a higher speed. And we actually have some things built in, and I think this is the next slide, to help you with this. So again, going to drop frames, we have this high-performance parser set, which is basically a pared-down set to filter on the most popular things you want to filter when you're doing capture. So stuff like IP address, TCP port, MAC address, UDP port, stuff like that. So you can either manually set this profile, or there's another way to trigger it. And so we have this feature in 3.4, which we call high performance filters. And by using a fully qualified path, frame dot, instead of normally you type in a filter ethernet.address, well, we're giving it the full path, frame.ethernet.address. This triggers something called this high performance mode. It automatically selects the high performance user profile and plumbs down a high performance filter. So I'm not going to go into too much detail about this, but in the UI, there's a list of these high performance filters that you can look at and figure out how to use them. There's probably about, there's many different variations, but overall there's like 6 or 7 of these types of filters that you can do. Now the trick here is it's fully qualified, so you kind of have to know your network structure. If you type in frame.ethernet.ipv4.tcp.port and it's over IPv6, you're not going to see that traffic. And the reason this is fast is because we don't have to make any decisions. We don't have to say, is it IPv6? Is it IPv4? This kind of simplifies the filter in our we can get it. Basically, it's an offset that we can match in the end with a few decisions that have to be made. And then finally, there's another way to avoid drop captures, and there's certain dials you can change in the engine buffers, number of buffers you can that we use to capture this information. I have a blog. I'm not going to go into detail on this, but I have a blog that explains these. It's also in the documentation. So if you get to a point you're still dropping frames, there are a couple more things you can do. So any other questions on this slide? So capture file formats. We support any network monitor capture. Yes, question? Okay, so the question is how do we decide what to drop? So again, there's 2 cases. The one where the NIC drops it and we don't have anything to do with it. the decision for us to drop it is the way we work is we actually buffer this data in a buffer before we access it. And we have a quota, a size that we use for that buffer. So one way we decide is that if we run out of buffer space, we drop those frames. So that's one. The second one is that we have this, again, these registry entries I mentioned. We have this set of buffers we use that are also used kind of like a pre-buffer, I guess, before we stick it in the buffer pool. And once we get to a point that we use up all these buffers, we'll also drop frames. So it's really just a matter of losing or running out of resources, those two resources, which tell us whether or not we'll drop a frame. Okay? Any other questions? So we support the network monitor capture. The latest version, in the 3.4 version, we actually have this new feature that supports this idea of time zones, meaning if you take a trace in India and you move the trace over here, the times will sync to your local times. The old version of Network Monitor would work by, if you took a trace in India and it's 4 o'clock and you open up, it says 4 o'clock. That's the way the old version works. And both are actually useful for different scenarios. So you can still get back to the other way of doing the trace. And as a comparison, the way Wireshark works is it says, all right, I'm going to timestamp based off of GMT, and that's what you're going to see. So they each have different ways of doing it. So just keep that in mind when looking at the timestamps. So we also can load the PCAP version files in Network Monitor. It has to be 200 or greater, and Wireshark has a little bit of fragmentation around the PCAP file format. So I can't swear to you that if it's 2.1 it's going to work, but for everyone I've seen it's worked. There's been maybe one case where it hasn't. It was due to this different way of doing a 2.1 action. All right, so now diving deep, let's go in and figure out how to do filtering, how to look at the data, and talk about the conversation tree in a little bit more detail. So now you've got a trace. You've done all this work to get a good capture. Now you want to look at it and explore some of the data and find what you're looking for. So we have different ways of doing this. We have a conversation tree, so we'll talk about that in a little bit of detail. You can find frames with filters. You can filter them out or search for the next match with a filter. You can use friendly names for network addresses. So this means using a name rather than an IP address or a MAC address, something you tell it, or something we resolve, name resolution from the trace itself. Talk about digging into the frame details, reassembly, something we don't do on the fly, but you can do with a button press. How to annotate captures. You got a capture, you want to put some notes in it. So you pass it on to somebody else and they can look at that capture. And then finding the protocol documentation references. You see something, you want to know where it is in the documentation so you can do some comparison. All right, so I'm actually going to, this is where we're going to get off the bus. Space for a mouse. Doesn't seem to be working. All right, so here's Network Monitor, and as I've mentioned before, this is the frame summary. So when you click a frame, it populates the frame details, right? Makes sense. We now show the details for this frame that we've selected. And so you can see we have this tree structure. I can dig into TCP layer and see different things. And then you also notice that when I select something in the frame details, it highlights the section in the hex details. So if there's any question about the parsing or you want to see the raw data, you can do that. But what's also kind of cool is you can go backwards. So let's say that we have an interesting frame. I see a bunch of stuff in here. And I say, okay, well, I see this data over here. I want to know what it is. I can double-click in the hex details, and it'll highlight the associated data on the other side. And so in this case, I don't know why that didn't work. Here, I'll do the FFE. Okay. Normally that works. I don't know why it doesn't work right now. The other thing that's kind of interesting is that you can copy this data out into an ASCII format that you can share with people. You put it in your case notes, put it in email. So the way you do that is for the frame details, and this works in all our windows, by the way. So let's say I want to show you the TCP details. I'd open those up, right mouse click, copy tree, and then if I was going to paste it into something like Notepad, it pastes an ASCII representation. So some people will just cut pictures out, and the problem with pictures is sometimes you cut off the end, and that's the information that I just happen to know. But this is a little bit better, I think, a little bit easier to use for the receiver. And again, you can do the same thing. I can copy. So this is kind of cool. I can copy about a bunch of information out as row data. It's tab-separated information. So when I copy this data, it actually copied those as rows. And so if I paste into Excel, it'll show up as, in columns as Excel for you, so that's kind of cool. Another thing I like to do is I'll paste in the mail. It looks like a bunch of crazy stuff, but our tools are kind of smart. If I convert it into a table, it actually converts it into a table for you. So I do this in mail a lot of time, and then I cut out the columns I don't need, so I think that's pretty cool. And then you can also do it in the conversation tree. You can do it in the hex details. One interesting thing about the hex details is the format. There's probably multiple ways people want it. We do it's just a stream of hex first and then the ASCII later. So people say, why don't you show the same view? I guess that would be useful too. But this is kind of cool if you want to paste out a long string in here. This is the only way you could do it, is if it was a long string. So we just decided to take one option rather than presenting a bunch of different ones. I think something we can improve upon in the future. Okay, and the last thing was the decode as. So we also have, there's some data in here that is, like say this didn't actually parse as SMB, I could say decode as, and then choose what I want it to parse at. It'll open up a new window with decoded data. Now what invariably, somebody always asks, and so instead of you guys asking, I'm going to tell you, you can't, I think the request here is that sometimes you have a stream of data, a bunch of TCP data that is all SMB, and you want to decode the whole stream as a specific protocol. There's no way in the UI to do that. There's no way to say right-click, parse as SMB, but there is a way around this, and this is by modifying the parser. So I have a blog on this. There's a fact, so hopefully you can find the information, but it's not that hard. There's a case statement. I'll show you these parsers in a little while. It says case 445 for SMB, so you just add in whatever port you want to parse. Rebuild the parsers, by the way, are included all in the product, and then go on your way. So it's a workaround for what happens to be, I mean, it's not common, but it does happen every once in a while. Yes, so I will show you, we do this through our conversation feature, and I'll show you that in a sec. So let's talk about conversations. Any questions on that before I move on? Okay, so what exactly are conversations? So they're a logical grouping of frames, meaning that we think they should go together. We kind of lock them together in the parts of trees. They're a visual way to zero in. So you can click in the conversation tree, and it's going to filter based on what you've clicked on. So for instance, if I click on iExplore in the UI, it'll show me all the traffic that iExplore has generated in that trace. Kind of a quick way to filter. It's hierarchical. So Internet Explorer consists of a bunch of different IPv4 connections, which consist of a bunch of TCP connections and so on and so forth, depending upon how many of these parsers define conversation. It includes processes. So like I told before, we collect process information and allow you to look at it, explore it in our conversation view. And so this is obviously a cool feature. If you know what process it is, you don't have to figure out the filter. You just click on the process. It makes it really easy to find traffic. It's also kind of a cool way to see what your machine's doing. I often sit there and say, wow, why did this process, what is it doing sending traffic? So kind of a cool way to find viruses and exploits. Another thing it does is provide state. So we used to default with conversations off. It's on now. You can turn it off to save memory. You've got a really large trace, also a little bit faster. But in many of our parsers, it provides state, meaning that if there's some state information, for instance, a RPC call. An RPC call will do a bind on one frame, send the GUID, and that GUID never appears again. So if you're missing that first frame, it can't parse. There's no one can parse it. We just don't know what that information is. So we save that as state in the conversation. So if you turn conversations off, there's some protocols that won't parse properly. And so these kind of go together. It's required by some parsers. Some parsers won't work. SMB won't work properly unless conversations are enabled. And then it's kind of cool. It's defined by the parser. So in our parsing script, you as a developer, parser developer, could define what a conversation is. And so this is not limited to just connection-oriented protocols. You could define a conversation for a UDP protocol as long as there's some common state, some key you can use to tie those frames together. So anybody can define these if you are so encouraged to figure out how to do that. Any questions on what conversations are? No? So here are the clever tricks. And so I'll show you some of these, but basically when you select a conversation, it filters on those like I showed you before. You can right-click and find conversations. This is the follow the stream feature, and I'll show you how that works. This is kind of cool. You can scan children. So if you look in the conversation tree, it organizes all this data for you. You can, maybe I'll just show you right now. You can look at, let's say, for instance, that I'm in this trace and I see this session set up. So here I'm going to do the follow the stream. So it's called Find Conversations. And so the difference is in Wireshark, you only follow, well, I think there's more than just TCP, but TCP is the one that shows up follow the stream, I believe. And so you can do TCP, follow the TCP stream. So if I select that, it selects it in the tree. And by selecting the tree, it automatically filters on this. So now there's another part of follow the stream, which opens this box and shows you the hex and wires. We don't do that. We just basically show you the traffic that is associated with that TCP stream that you select, or that conversation that you selected. So I could also find SMB conversations or IPv6 conversations or what else is defined. So it kind of gives you more choices than just TCP streams. Now, when I jumped here, I was talking about you could find other associated traffic. So once I get to this point, I can quickly click. In fact, I can just down arrow on these over here. I can see what's happening at a high level. Because I know these are all hierarchical. They're all associated with this one particular TCP session. And so now I can just look over here and say, okay, this is a create, another create. Oh, look, an error on this one. Maybe I need to dig into here. So it kind of gives you this very high-level view that you can sort of scan a trace without having to dig into all the frames. So I think that's pretty cool and pretty useful. And I guess the two other things I mentioned is you can only select one thing at a time in the conversation tree. And sometimes you want to see, I want to see both. I want to see this traffic and this traffic together because they're associated. So the workaround for that is you can actually copy the conversation to the clipboard and then paste it in here as a filter. And then so I could do two of these, right? And I'll just use parentheses to make sure. And I could say or, and then I could do this one. Copy conversation to filter to clipboard, paste it in here, and now I can see those two pieces of traffic. Now, I hit Control-Enter, and so people get confused by this sometimes, so I'm going to bring it up to talking about it. It only shows me one frame, yet I've got a filter for both of these. So does anyone know why it's not showing more than one frame there? Anyone figure out? So the reason is because I still have the network conversation selected. So I'm doing two things. I've got a conversation selected and a filter, and it ANDs them together. It ANDs both of them together. And the clue we try to give you here is to say, this is the filter that's applied, conversation filter, comma, and your conversation. So to get my filter to work properly, I have to go ahead and click on all traffic, and now I see at least 2 frames since I have 2 conversations selected. That makes sense? So some people get confused. They apply a filter, nothing shows up, and it's because something's selected in the conversation. And then I talk about a virtual filter on conversation tree. So sometimes you want to filter on the conversation tree, right? You say, okay, well, I have all these nodes, but I want to see a subset. There's no way to do that in the UI, but you could work around this by creating the filter, saving it out to another file, and then loading it back in. So kind of a workaround if you ever run into that situation. Okay, so that was conversations. Any questions on conversations? No? All right, so let's talk about filtering in general. Yes? Okay, so the virtual, so you want me to repeat the virtual conversations but filling a tree. So let's say that you have this huge conversation list and it's, 40,000 ports. And you're like, okay, well, I'm only interested in HTTP traffic. So ideally what I'd like to see is the conversation tree, but I'd like to filter out everything else that's not HTTP. And you can't do that. You see all the conversations. But what you can do is you create a filter, say TCP port 80, filter all that data, and then just save that subset to a different file, open that file up again, and then you'll only see that part of the data. That makes sense? And so that's just sort of a workaround for that scenario, because people have asked before, they want to filter in the conversation, but you can't. Okay, so the first point of emphasis here is all filtering is the same. You don't have to worry about capture filters versus whatever, display filters. In fact, display filters, capture filters, and MCAP's the same. Our color filters are the same. If you want to create a color filter, it's the same filter language. And then finally, if you need to do a find, like I want to find the next frame that has port 80, it's the same thing. It's just another filter. It's all the same. So we tried to keep the filtering language consistent so you wouldn't have to learn 2 different types of filtering languages. We have standard filters. So these are built-in filters over here to help you learn. So if you're trying to figure out how to do a filter, check here first. It might already exist. In fact, all the basic address like IP, IPv6, subnetting, these are all here in the address filter. And we have a bunch of others. Filter out noise. You want to get rid of remote desktop traffic. We have a filter for that. So this is a great place to start if you want to learn how to filter. And you can save your own filters there as well. And I'm going to talk about CodePlex and the parsers in a second, but we update our parsers monthly, include color filters and standard filters. So there's some more things we update on a regular basis. So there's a filter you guys say, we use this filter all the time. I think it's used for everybody. We can add it into the product so you guys can, everybody can, we can share that information with everybody. We have IntelliSense for building filters. So I'll show you this real quick. So you might not know, you're kind of starting fresh and you're like, okay, well, I want to build a filter and you don't even know where to start. Well, Dot is probably the best. If you start with Dot, it starts with the IntelliSense and shows you the high-level information. There's a lot of things here, but for the most part, you'll choose, let's say, protocol, Dot, and it gives you a list of protocols. So now you can find TCP, whatever you need, and it goes on and keeps on helping you as you go through. So this is kind of a helpful way to build filters. And then finally, in our help file, which from the help menu, you can get more, general help on creating filters. Obviously, creating filters is what you do the most in these protocol analyzers. So we have different, ways to help you. And the blog has some more information. There's videos as well. So if you get stuck, there's lots of resources for that. All right, so clever tricks with filters. So again, the dot is for IntelliSense. We just talked about that. Color filters are trippy. They're kind of cool if you want to highlight or make some piece of information stick out. I want all SMB errors to be red. Let's create a filter for that. Finding frames like this one. So this is another easy way to build filters. So let's say that we have a bunch of data, and we're looking at a specific frame, and we're like, all right, well, the fin flag is on here. I want to build a filter on that. Right-click it. add as display filter, or you can create a color filter too. That's kind of cool. And now it builds the filter for you based on the value you selected. Now, it's always based on the value you selected. So, for instance, if I did ports, I wanted to build out a port filter, it's going to stick in the address here in hex, ED03. And so I could change that and say, oh, I didn't want that. I wanted 80. And apply that. Okay, so the next thing here is that, okay, source port. I really wanted source and destination. I wanted it both directions. Well, we have some special, the term port is not something that appears on the wire, right? This is something we made up, allow you to automatically do the directional, directionless type filter and get traffic in both directions. And this trace doesn't have any port 80 traffic, maybe. I think it's SMB trace, so it probably has 445 traffic. And we have this for a couple other things, IPv4 addresses, IPv6 dot address. Again, this is a special property that allows you to filter in both directions. And so this right-click add to filter also works with columns. A couple of caveats, but in general, I can right mouse click and say, and you click on the actual description, so I could say, all right, I want to add a description to find something in this text. I want to do a filter on that. So this, again, it puts in whatever I right-click, but you can do this for any of the columns. So I think I'm about to show you this in a second anyway, so I'll do it. So there's also a special plugin called Contains, and that's like searching for a string and a string, right? So I could say, I want to search for anything that has dev support in it. And again, this is searching this particular column text for this data. So it's just another way to create filters by right-clicking. That makes sense? Yes? Yeah, so the question is how do you know that there's a contains? And probably what other functions are not shown up in IntelliSense? Yeah, IntelliSense, we didn't show those. We probably could have or will in the future. One way you can, and so it's, when you do the dot, there's two ways to do contains. So you can do contains the way I did it, or you can say description, comma. And so it's like this special function that can be used as part of the object itself. But you can find these with the dot. I think this is where it is. No. Well, I thought it did exist in here. I'm not 100% sure. Yeah. So here's I went to the parsers tab, and in the plugins, it shows you all the plugins. So there's more, a lot of these plugins, in fact, all the plugins are as part of the parser language. I mean, this is like we're exposing parts of the parser language. And so contains is in there. Contains bins is another one we're going to talk about in a second. They're not very discoverable, but they are in the help, and a lot of them are in these built-in standard filters. Then finally, find frame. So again, this is the idea that you can, hit Control F, and now I want to look for where the description contains opla. I want to go to the next description that contains opla. And it didn't happen to match in this case, but I can go one by one and find each. Rather than filtering out the whole trace, I just jump to the next instance of that particular filter or instance. So here are just some general filter examples, and this is what you find in the standard filters or in our help, but you can always just type the name of a protocol. So in this case, it doesn't say .protocol, .MSRP. Once you know what the protocol is, you don't have to preface it with all the, the fully qualified name. Like it just said, MSRPC or LDAP. It's a filter that finds all that traffic, either one. TCP.port equal 80. You can look for the process name. If you wanted to filter on everything that had iExplore, or maybe do a contains and look for everything that has some prefix, you can do that. We have these things called properties, and properties is kind of like this metadata that we build based on the frame data. So for instance, a good example of this is a file name. SMB has a file name in many different places in the protocol. And so rather than you have to type in the full path or part of the path, smb.request.filename, smb.response.filename, we create this property that encompasses that value wherever it might appear. So it makes it more convenient to create a filter. So you can use IntelliSense to find these properties. The list of properties is huge. Properties are kind of overloaded. But we do usually put the name of the protocol before it. So if I type in, for instance, if I type in property SMB, I'll find all the SMB related. In TCP, I found all the TCP. So for the most part, we've done a good job of at least prefacing so you can kind of find them. But again, this list is huge, and sometimes knowing them up front helps, or looking again at the standard filters and some of the help files will help you figure out what the most common ones are. So color filters again, kind of cool for making things pop out. You can show all TCP retransmits in orange if you want to make those stick out. Parser errors in red. So we have this idea that, if we ran into a problem parsing a frame, we could make those stick out. And we can help our protocol documentation people find errors in our parsers or in the documentation by making these things stick out. So what we did is, in some cases, for instance, a frame doesn't fully parse. There's SMB data and there's some remaining frame there. We flag a parser error. And so this kind of gives you a cool way to find errors in your protocol without reading documentation. You can apply an error, see if any parser errors pop up, and if they do, it's possible that either you're not adhering to the documentation, or there's just a frame that's not fully parsed. Maybe it's a documentation bug. It's possible that as well. But this kind of gives you a cool way to find those types of problems. And if you're looking for, this might be your first step. If you think that you have some interoperability issue with your implementation, you can run this and see if anything pops up. But again, it's just another property that we build as we are building our parser. So here's the contains that we just talked about. And then contains bin. So let's talk about the difference between contains and contains bin. Contains is case insensitive and type insensitive. It'll search ASCII or Unicode for you. So if you look for a property or feel like an SMB file name, it can be Unicode or it can be ASCII. Contains will do all the work for you. Find either version of that data. Contains bin is different. Contains bin doesn't do, it's case sensitive, it is type sensitive. You have to tell it what type you're searching for. The advantages is that contains bin works on binary data, and contains does not. Let's say you have this big blob, a TCP payload. It has some ASCII data in it, but it has a lot of binary data in it. And it has some text you want to find. Contains won't find it. It'll stop as soon as it finds the first non-ASCII character. It's just not very smart. Contains bin will find it, except you have to tell it what you're looking for. Is it ASCII? Is it Unicode? So somebody might say, well, what if I want to search for both? Well, you can create a filter that does that. So let's do contains bin. So the first parameter is what you're searching. 99% of the times, you just want to search the whole frame. I want to search the whole frame for data. Second parameter. Okay, there's different options here. And so rather than telling you to memorize this, I'm going to tell you a trick to find out what they are. And what we did is we have a standard filter called search frame that has all this information in it. So it tells you that the first thing is a type. We built some constants for these types, so you don't have to type 0, 1, or 2. You can type for hex, you can search for ASCII, and you can search for different types of Unicode. So one of the engineers that came up to me and said, I want to search for Unicode. And I said, well, which kind of Unicode? UTF-16B? He's like, no, Unicode. I just want to search for Unicode. And so, maybe they're not aware that these different types. So we also put in this little looking for Unicode. This is probably what you want. That's 90% of the time, unless you're looking for, some other version of Unicode. This is your best bet for Windows servers. And so you can specify, you need to specify the type, but if you need to do both, you can do an OR, the two, for ASCII and Unicode. If you want to look for case sensitivity, well, you either got to do all the versions, all the permutations that you need, or assume it's all capitalized or lowercase. So not quite as easy for that. Any questions on contains bin? Yes? So the question is, how do you search for hex? So let's do that. Oops. And so all it is a string of hex data. And so actually, this is where this kind of comes in handy, and one of the other reasons we use this method for a copy and paste. Oops. This laptop has something wrong. But that's how you enter it in, and then it would find found the one frame, obviously, that I stole it from. Space separate, yes. So does it have to be space separated? Yes, it does. Another question? So for Windows machine, what? So I guess the question is it usually big endian or little endian? Why is it usually big endian? Or why did I say it's usually big endian? So for stuff like SME, so for this particular Plugfest, file sharing, all of that's big endian. It's all, the Windows machines in general are big endian, and I'm not sure about Linux boxes, but the old Unix servers used to be little endian. And so let me we can talk after. I'm pretty sure that it's big endian. I mean, it's the Intel processors have always been big end in, meaning the other. It's always revert. You always got to do the funny reversal thing, but okay. Is it a little? Okay. Well, if I'm wrong, we'll fix it in the description. So, any other questions on filtering in general? No. Okay, so aliases. So you got this huge trace, it's got a bunch of numbers for IP addresses, and you don't know what they are. But you have a mapping. You can say that this IP address is my server, and this one's my client. Aliases allows you to create friendly names for these things so that when you view them in a trace, they make more sense for you. And you can do this for Ethernet addresses, IPv6 addresses as well. You can do this one by right-clicking on a frame and say create alias for source address. You can save this as a default. So if you have a bunch of systems you always use, you can save this in a file and load it up again. So related to this is that these names could also be resolved names. The parsing could find like a DNS resolution for an IP address, and then we'll use that for you. So another question that always comes up is that, all right, well, so now I see the resolved name in there, but I want to see the IPv4 address. I don't want this resolved name. And so there is a way to do that, but what you have to do is actually add a column in for that. So what we do is each of these columns, I don't know why I don't have destination, are properties in our parser language. And so what we did with source is this special property that says, all right, if there's an alias, use that. If there's a resolved name, use that. And if nothing else, then use whatever the IP, the raw address is. But what you can do is say, okay, I don't want that property, that special property that does all this resolution. I just want the IPv4. And so, by the way, you can type in here IPv4. And I can find I hope I can find. Well, let's just say in this list, there's the IPv4 address that you can add in specifically if you don't want to see the resolve name. And that's how you get around that problem. Any questions on aliases? Okay, so reassembly. This is kind of important for one reason. We don't do reassembly by default. So if you open up a trace and you're looking for a complete reassembled packet, it's not going to be there until you hit a button to do it. And it's important because fragmentation can happen at different layers. TCP could do it, all these different protocols. Some of them have different fragmentation strategies. But they're not automatically reassembled. You have to hit the reassembly button, and what happens is it opens up a new trace with all the original data and new frames added in for the reassembled packet. I'm going to show you that in a second. Or I have some slides to show you this. It's only available on a saved trace. So if you're doing a new trace and you try to, there's no reassembly button. You have to save it out first and load it up. It's one of the limitations. So it opens this new window and inserts frames. So what does this look like? So the first thing is how do I know I have to do reassembly? Well, one of the clues here is if you see stuff like TCP continuation, probably means the data has been fragmented. And we show this kind of flag at like the MBTSS layer and some of the other layers. So once you see this sign, you go ahead and hit the reassembly button. A new window opens up. The new frames are inserted. Frame numbers won't match anymore. You can use the IP identification if you need to map that to the original trace for some reason. The new frames are inserted, and they look similar to the original frame. So in this case, frame 75, the top one, is the original frame, and 177, which is underlined, is the inserted frame. They look identical, actually, and it's because they have the same header information, and we were able to parse far enough into the request to show you the same data. But there is a difference. So what I've done here is I've created a color filter to underline. I use this color filter idea to make sure I can find these reassembled frames and differentiate them from the original frame. So I created this color filter called payload header. So now you're going to ask, well, how does that even differentiate the frame? So the way this works is that when we insert the frames, we create this new header to put the reassembled data on. And the reason is that TCP header that was there wouldn't make sense anyways. It's not, size is not going to be right. In fact, the rest of the stack doesn't really make sense because it's multiple frames. So rather than try to doctor up a fake TCP frame or do something wacky like change the TCP data, we insert this new payload header object on top, which has some of the information about the original frame, like the ports and the addresses that came from the original frame. And then we have, as a payload, the HTTP data. So now this similar frame has been inserted, frame 177, and it has all the data, the whole packet, all the fragments have been combined into one in this new data. So probably the takeaway here is sometimes it's challenging. You do a reassembled trace, you're going to have to go find these inserted frames. And this is one way to do this. And this is something I just thought of that I need to add. So I actually have a blog that takes us one step further, where you can create a filter that shows you only reassembled frames. So you might think that, well, why don't I just do a filter, a payload header, and I'll just find all the reassembled data? Well, not everything's fragmented. Only parts of it are fragmented. So if you do that filter, you're going to only see frames that have been fragmented, and you're not going to see all, like, the request is not, the original non-fragmented frames aren't going to show up. So I have this special filter that I can use, and it's on the blog, that allows you to see this, to see either things that have been fragmented and complete, or frames that weren't fragmented to begin with. And it's actually, I can show you it because it's easy to find. It's specific to each protocol. So for HTTP, we have HTTP complete frame. So if I apply this filter on a fragment, this is obviously not a reassembled trace, it'll show you just the complete frames or the things that weren't fragmented to begin with. And there's one for TCP and one for MBTSS, which is what SMB is fragmented over. MSRPC is, no, I don't have, you mean as far as the special operation? No, I don't. So usually MSRPC is fragmented over TCP, though it can do its own fragmentation. It would be possible for us to probably create a property in the same way. So, I mean, is that something you'd find? Is this something you've run into before? Okay. Oh, you did? Okay. Okay, so yeah, so the question again is, does it work for MSRPC? And I guess my response is something we can look into. And so, as I said, we update the parsers. This is something that we can update on a monthly basis. So maybe in one of the future monthly releases, we'll have something to address that problem for MSRPC. Yes. Okay, so the question is this include IP fragmentation? And so reassembly is done at all layers. So if you have a HTTP frame that's fragmented over HTTP, and then over TCP, and then on top of IPv4, it'll all be put back together again. And so what actually happens is for every time we put frames together, so let's say that we had two IPv4 frames that made up a TCP frame because the router fragmented it. We'll show one inserted frame for the TCP layer, and then we combine all those TCP frames into an HTTP frame and insert that, and then we, for each HTTP fragments, we put those together and put them in there, and then we show you the final HTTP full frame. So every time there's fragmentation, we insert these new frames, and you'll see them at all different layers. So for instance, we have traces where, HTTP doing chunking, it chunks up data, and it can do fragmentation on top of TCP. And so you see all these, that's where it becomes confusing, because you have, every time we put something together, we stick a frame in there for you, showing the defragmented data. Okay. Yeah, so the question, or the restating the question, is that when you're in Wireshark, you can see the complete fragment by doing the follow the stream, and it opens up the window and shows the request and response data. In Network Monitor, you could do the same thing by doing this HTTP complete frames, and we'll reassemble first, run this filter, and it'll show you only that HTTP data that's been reassembled. And then if you want to see that same view that Wireshark shows, you could actually add a column in for the payload, for the TCP payload, and see, or for the, actually since it's reassembled, I'm not sure that would show. So I don't know if there's any way to see the payload per se as ASCII text, like in the dialog box that Wireshark shows you. It'd be possible to create an expert to do that. It's actually something I started fiddling with, and I think it's pretty easy to do. But you can at least see that data, and you can click on each one. And so you can open up the frame and see the full payload for one direction, for one request or one response. Does that answer the question? Is there another question? No? Any other questions on reassembly? Yeah. Yeah, so the question is, can you do reassembly during capturing? And there is actually a parameter on NMCAP to say reassemble the data. So to be truthful, I've never used it before. I know it's going to eat up CPU and probably slow down things, so I'm not sure it's, at least for high capture scenarios, it's that a good idea. But you could do it in a low capture scenario, and the resulting trace will have these inserted frames in them. So you can do them on a live capture. Yeah, okay, so the comment is that there's some cases where you need to create a filter that's based on the reassembled data, and you're exactly right. In some cases you need the full frame in order to create an accurate filter, and that's one case where it'd be useful with NM. So you can do it with NMCAP, not the UI. You're right. Okay, any other questions? So frame commenting. So this is the idea that you get a trace and you want to put some information in there. You want to say, hey, Joe, this frame 35 looks really messed up and it has this value here, and you take a look at it. So we decided that what if you could put that information in the trace itself and make it part of the capture so that when you send Joe this capture, he can open it up and look for your comments and figure out what's going on. So this is what this frame annotation feature is. So what happens is you select a frame. We have this frame comments that shares in the default setup, which, by the way, you can change the windows and however you want set up. In frame comments, you can edit and add a new frame comment. It brings up a dialog, and now you can got to select the frame first. Brings up a dialog. You can put a short title there. And then a description. And in the description, you can type in whatever you want. The other cool part is it's rich text formatted enabled. So if you have some rich text that you paste in there, like for instance, if I was running right, and this is cool, and I wanted to make it a specific color, and I wanted to make it big or something to make it stand out, it'll remember this for you. So it's kind of cool. You can do some formatting, and actually maybe a better use of this is that I could take this information, make sure that's going to work, and now I can highlight something based on what I copied out of the data, and then put it in there, the whole, the frame detail, so I can now sort of point out what's wrong in the trace using this rich text format. So that's kind of cool. So another way we've actually used this particular feature is we've done this thing on Codeplex, a project where we've taken some traces and we've documented them for you to describe certain documentation behavior. And so this is called sysdoc on Codeplex. So I always just search for sysdoc Bing or whatever. And this page comes up, and then under the system overview document scenarios, there's a list of different scenarios which has groups of captures in it which have these annotations for you to figure out how things work. So, for instance, for the file systems, there's the FSSO scenario captures, and there's different ones based on what you're interested in doing. And so we didn't document everything, but there's just certain key scenarios we decided would be kind of cool for you to look at. And so once you open up that trace, these annotations are in here. And so I've opened up this FSSO S3. And so the first question is, well, how can I find the comments? Well, easiest way probably is next comment. And so the first thing you notice is under the frame, it's got the little hash mark, means it has a comment. You can use next comment to go to each one, but you can see in this case that we have a description of the section that we're describing, live links to the documentation. And then you can go to the next comment and see what the next part of this, in this case, an SMB com negotiate. So it's kind of a cool way to help you guys understand how certain traffic works, and certainly a good way for you to document problems and store information in the trace. Okay, so the last couple sections, probably not all that important unless you're really ambitious folks and want to write your own parsers, but there are some cool things inside the parsers that might still help you out. So first of all, they're written with a concise language. MPLs are this kind of language we developed for creating these parsers. It made our parser development extremely fast. Very simple to write these parsers. I once wrote a parser in 4 hours for, I can't remember what it was now. I think it was WINS, the old Windows resolution protocol that we had for a long time ago. All the source code is shipped in the product. You have access to it all right from the tool. So this is kind of cool. If you want to even explore, you just go to the parsers tab and look there and find what you need. I'm actually going to show you that in just a second. It's updated basically monthly on CodeFlex. So every month we go out there and stick a new version, new parsers, new documents, new parsers for new documentation exists up there. Parser fixes, color rules, everything can be updated. So you should go look here monthly. It's also linked on the start page, and update your parsers frequently. You could write your own parsers if you want to, or customize the existing ones. For instance, if you have a summary line that you don't like, it has too much data, and you just want to make it simple, it's a pretty simple change to make in a parser, actually. You can create properties if you have some metadata you want to stick together. You could do that. You can specify how the data is reassembled if you want to reassemble some protocol. That's done inside the parsers. And it also defines what a conversation is. So if for some reason you wanted to create your own conversation, you could do that as well. Probably all that stuff is not something you'll delve into, but this might be useful. So for instance, you might be wondering, you'll be looking at an SMB frame and you'll go, okay, so I see this flags 2. I want to know what it means. I don't really understand what this data is. And so there's no easy way to jump right to the document. That would be pretty cool, wouldn't it? But instead, you can go ahead and find the definition in the source code. So this jumps to the source code and puts the focus on that particular field. So maybe that's not that helpful, but what really is if you need to know the document where this exists, at the top of the document, we tell what documentation makes up this parser. So you could go do a search on SMB, find the document, and then we also name our fields in the parsers based on what's in the documentation. So you can just search for flags 2 and find it in the documentation. So we have a close relationship with the documentation, so you can easily associate information in the parsers or in a trace to the documentation using this method. Do you have a question on that? Then I was going to show you the parser tab just for the fun of it. So this object viewer has all the files and all the protocols, and you can go open up TCP and see how it works. You can make a change to it, and you can use the rebuild parsers to rebuild it. So you can make changes and play around with the parsers if you want to learn how they work. And then when you compile, there's errors at the bottom. So if you have an error, you can try to figure out what's going on, what you did wrong. Okay, so we're going to talk about, this is the last 2 sections, the API and experts. And this is, again, this is probably more like overview information, but we supply this API, and it allows you to do a couple of things. So first of all, the help file contains examples, all the reference for this API. All the files for building are included, or at least the lib file, the ACE file, you need like Visual Studio or some build environment to create programs with the API. The DLL is in the Network Monitor 3 directory, so it's in the path automatically. The one key thing is it's not redistributable. You can't go passing this DLL. What we say, if you want to create a program with the API, we ask that the user installs Network Monitor. And the reason is we don't want to get in the situation where you distribute a DLL, and then we distribute a new one, and now they have the old one lying around, and the DLL hell that we've had in the past. We didn't want to get into that particular problem. Any questions? So what can you do with the API? Well, you can read and write capture files. Makes sense? Capture live data. So you want to program or automate something to capture live data during a test process, you can do that. Very simple, by the way, 3 or 4 API calls to start a live capture. You can filter live or capture data. So, these filters that you use in the UI are the same filters you use in the API. It's just a string that you pass to act as a filter. You can inspect all the data fields. So any of these data fields that you see in the UI, you can get the data back for those, the TCP flags, whatever. You can read properties and comments, all that's available to you in the API. You can also get the formatted descriptions that we show in the UI. So if you wanted to duplicate the UI, you could do a lot of that and show those formatted descriptions that we show in the frame details. And then finally, you can access conversation information. Mm-hmm. Mm-hmm. Okay. So the question is can I take like MAPI data, for instance, and modify the raw data and somehow use to parse that data after it's been modified? An XOR example is the one you gave. And so I think yes, you can do this. There's probably a couple ways, but the things in the API that you use to do this is you can get the raw frame data. You can use the parsers to find the blob you want to decode. For instance, if it was a TCP payload, you could figure out where that payload is and pull that blob out. Then you can decode, XOR it. And then so now you have the issue that if it's the same size, you probably just plug it right back in and then write out that data to a new capture file. Or you could reparse that raw data based on the XORed information. So you could, there's probably multiple steps here, but yes, you can do that with the API. So I guess the answer is yes, you can do it with the API. The detail, devil's in the details, and I think I could help you if you wanted to figure out how to do that. But it's basically just taking that blob, changing it around, and saving it out again, and reparsing it or reparsing the blob. All right. Yeah. So the question is, are there decryption APIs for this data? So yeah, so we don't, so decryption is not obviously just one thing, right? There's many different types of decryption. So we don't have, and probably don't plan to do anything in the API itself for decryption. So, but what we have done, and this is really the next slide kind of, is we've created these experts that allow you to do the decryption based on the same method I just showed you. So we take the frame, take the blob out, we use whatever decryption algorithms, then we save them back to a capture file that you can then open up again. So it's kind of a two-step process. It's not, parse, decrypt, and show. It's parse, decrypt, save to a file, open up a new file, and then show that. It can be done pretty seamlessly. As an expert, that's what the decryption expert does. And while I won't show you that exactly, it's the same idea, basically. So I don't think we're going to put any decryption APIs, but at least expose it in such a way that you can plug in these APIs, I guess. Does that answer the question? Okay, so the question is if you do a capture with Wireshark, you're not going to have that process information in it. And how many of the filters are going to, what's not going to work if you open up a PCAP file, I guess is kind of, what kind of filtering is not going to work? And the answer is that the only thing that's not going to work is when you try to look for process information filters. So it'll load up, it'll still do the conversation tree, but you're not going to see any of the processes over there. It's just going to start at the IP, the network layer. Basically, we build our computation tree at IPv4 and IPv6. And then any filters that talk about process information, if you process equal IE, this is not going to return anything. It's going to assume that it's blank, null value and not return anything. Every other filter should work. It should really not. The only time it's not going to work is when you're explicitly filtering for process or process ID. So everything should work. They'll all work. Yeah, it's fair. In fact, there's two filter strings I know of that won't work, and that's process ID and process name. Those are the only ones that will work. So everything will work. You just don't get that inconvenience of seeing what process generated. All right? Any other questions? All right, and then finally, yes. So I didn't hear the whole question. So you say, is it possible to generate the process information in the capture file? So yeah, so the question is, can I generate raw data and put it into a capture file? Yeah, with the API, take any old blob, say it's a frame, and pass it out. So anything you can do. And in fact, that's what the decryption expert does. Is it says, all right, here's the blob. I'm going to decode it. I'm going to put a fake header on it. Again, sort of like payload header in the reassembly case, and then put the decoded information. Yeah, so Dave's saying we actually document the file capture format in our help file, so you could actually just raw create one yourself. You don't even have to use our API if you wanted to. And in fact, you could, I mean, potentially Wireshark could write process information in there. We document all that, so this is all open. You know, if somebody wanted to create a tool that did that, that's possible. So really quick, the expert analysis, these are tools that were written mostly with the API, though it doesn't have to be, that are accessible from the UI. So I know I'm kind of short on time, but what I'll show you real quick is the important part is you can find experts by going to the menu and saying download experts. And this will bring us to the CodePlex page, which has a list of experts that we've developed and other people have developed. And so we have the decryption expert, top users. A new one is top protocols. We haven't had that, I think, last time since I've given this talk. There's a TCP analyzer, which was written by our MS Research. It kind of builds this graph and shows you a graph of TCP requests running on your network. You can see if your network's slow and why. And then VRTA is kind of an interesting tool written by another group at Microsoft that analyzes HTTP traffic and kind of shows, you know, in a diagram how long each request, what's the, you know, what's depending on what else to start. So it kind of shows this, this diagram of information. It's kind of an interesting way to look at HTTP traffic and debug. It actually tells you to say, hey, if you turn this option on, your server will be faster or your web page will load faster. And so all these related tools, once you install them, appear in the menu. And the next thing that's kind of useful is there's help. You can run the expert, or you can open the help, which has a lot of information in the case of the encryption expert, what certificates are supported, what you know, what types of encryption are supported. So the help is a simple way to get that information. And in particular, for the decrypt expert, there's lots of the cipher suites that are supported and stuff like that. So anyone can write these experts and plug them into the API. On the CodePlex site, we have this SDK that tells you how to do that, how to plug it into Netmon. And I suppose is one of our takeaways here, since we're at the end, is that that's one of the things that I like you to think about, experts for your domain. So if you have this protocol, you have this problem that everyone's running into, it'd be really cool, you know, to write an expert to help everybody, and then we can advertise it on the CodePlex page, be an open source project. By the way, all the top 3 experts, Venom Decrypt, top users, top protocols, open source. You guys can contribute to them. We've had an external person contribute to the top protocols, top users, expert. So it's all available out in the open for you guys to play with. Visit CodePlex for parsers, and then obviously install and play with Network Monitor. Links at the end. Any other questions? No? Okay. Well, that's it. Hope you guys enjoyed.